The chemical compound potassium chloride is a metal halide salt composed of potassium and chlorine. In its pure state, it is odorless and has a white or colorless vitreous crystal appearance, with a crystal structure that cleaves easily in three directions. Potassium chloride crystals are face-centered cubic. Potassium chloride was historically known as muriate of potash. This name is occasionally still encountered in association with its use as a fertilizer. Potash varies in color from pink or red to white depending on the mining and recovery process used. White potash, sometimes referred to as soluble potash, is usually higher in analysis and is used primarily for making liquid starter fertilizers. KCl is used in medicine, scientific applications, and food processing. It occurs naturally as the mineral sylvite and in combination with sodium chloride as sylvinite. Chemical properties. In chemistry and physics, it is a very commonly used standard, for example as a calibration standard solution in measuring electrical conductivity of solutions, since carefully prepared KCl solutions have well-reproducible and well-repeatable measurable properties. Potassium chloride can react as a source of chloride ion. As with any other soluble ionic chloride, it will precipitate insoluble chloride salts when added to a solution of an appropriate metal ion, KCl, Ac, plus AgNO3, Ac, AgCl, S, plus KNO3, Ac. Although potassium is more electropositive than sodium, KCl can be reduced to the metal by reaction with metallic sodium at 850 degrees Celsius because the potassium is removed by distillation, KCl, L, plus Na, L, AaNaCl, L, plus K, G. This method is the main method for producing metallic potassium. Electrolysis fails because of the high solubility of potassium in molten KCl. As with other compounds containing potassium, KCl in powdered form gives a lilac flame test result. Physical properties. Potassium chloride has a crystalline structure like many other salts. Its structure is face-centered cubic. Its lattice constant is roughly 6.3 A. Some other properties are, transmission range, 210 nm to 20 AA micrometer, transmittivity equals 92% at 450 nm and rises linearly to 94% at 16 AA micrometer, refractive index equals 1.456 at 10 AA micrometer, reflection loss equals 6.8% at 10 AA micrometer, dNdt equals a 33.2 A, 10^6 per degree Celsius, dLdt equals 40 A, 10^6 per degree Celsius, thermal conductivity equals 0.036 with, Kmark, damage threshold, 4 GWcm2 or 2 joules per centimeter 2. 4.2 joules per centimeter 2, synthesis and production. Potassium chloride occurs naturally as sylvite, carnallite, and potash, and it can be extracted from these ores. It is also extracted from salt water and can be manufactured by crystallization from solution, flotation or electrostatic separation from suitable minerals. It is a byproduct of the making of nitric acid from potassium nitrate and hydrochloric acid. Synthesis. Potassium chloride is inexpensively available and is rarely prepared intentionally in the laboratory. It can be generated by two routes that are of instructive but not practical value. One way is to treat potassium hydroxide with hydrochloric acid, KOH plus HCl or KCl plus H2O. This conversion is an acid-base neutralization reaction. The resulting salt can then be purified by recrystallization. Another method would be to allow potassium to burn in the presence of chlorine gas, also a very exothermic reaction. 2K plus Cl2 or 2KCl, uses. The majority of the potassium chloride produced is used for making fertilizer, since the growth of many plants is limited by their potassium intake. As a chemical feedstock, it is used for the manufacture of potassium hydroxide and potassium metal. It is also used in medicine, lethal injections, scientific applications, food processing, and as a sodium-free substitute for table salt. It is sometimes used in water as a completion fluid in petroleum and natural gas operations, as well as being an alternative to sodium chloride in household water softener units. KCl is useful as a beta radiation source for calibration of radiation monitoring equipment, because natural potassium contains 0.0118% of the isotope 40K. 1 kilogram of KCl yields 16,350 becquerels of radiation consisting of 89.28% beta and 10.72% gamma with 1.46083 MeV. Potassium chloride is used in some dosing products that are designed to be safer for pets and plants, though these are inferior in melting quality to calcium chloride V. A 25 AA degree Fahrenheit. It is also used in various brands of bottled water, as well as in bulk quantities for fossil fuel drilling purposes. Potassium chloride was once used as a fire extinguishing agent, used in portable and wheeled fire extinguishers. Known as Super K dry chemical, it was more effective than sodium bicarbonate-based dry chemicals and was compatible with protein foam. This agent fell out of favor with the introduction of potassium bicarbonate dry chemical in the late 1960s, which was much less corrosive and more effective. It is rated for B and C fires. Along with sodium chloride and lithium chloride, potassium chloride is used as a flux for the gas welding of aluminium. Potassium chloride is also an optical crystal with a wide transmission range from 210 nm to 20 AA micrometer. While cheap, KCl crystal is hygroscopic. This limits its application to protected environments or short-term uses such as prototyping. Exposed to free air, KCl optics will rot. Whereas KCl components were formerly used for infrared optics, it has been entirely replaced by much tougher crystals like zinc selenide. Potassium chloride has also been used to create heat packs which employ exothermic chemical reactions, but these are no longer being created due to cheaper and more efficient methods, such as the oxidation of metals or the crystallization of sodium acetate. Potassium chloride is used as a scotophore with designation P10 in dark trace CRTs, for example in the skiatron. Biological and medical properties: potassium is vital in the human body, and oral potassium chloride is the common means to replenish it, although it can also be diluted and given intravenously. It can be used as a salt substitute for food, but due to its weak, bitter, unsalty flavor, it is usually mixed with ordinary table salt for this purpose to improve the taste. The addition of 1 ppm of thaumatin considerably reduces this bitterness. Complaints of bitterness or a chemical or metallic taste are also reported with potassium chloride used in food. Medically, it is used in the treatment of hypokalemia and associated conditions as an electrolyte replenisher. Brand names include K-Jaw, Clicon, Micro K, Slow K, Sando K, and KCl. Side effects can include gastrointestinal discomfort including nausea and vomiting, diarrhea and bleeding of the digestive tract. Overdoses cause hypokalemia, which can lead to paresthesia, cardiac induction blocks, fibrillation, arrhythmias, and sclerosis. Prescription potassium citrate can be prescribed as an alternative to potassium chloride. Slow K is a 1950s development where the medicine is formulated to enter the bloodstream at delayed intervals. It was first only prescribed to British military forces to balance their diets while serving in Korea. Some cardiac surgery procedures cannot be carried out on the beating heart. For these procedures, the surgical team will bypass the heart with a heart-lung machine and inject potassium chloride into the heart muscle to stop the heartbeat. The lethal effects of potassium chloride overdoses have led to its use in lethal injection, as the third of a 3-drug combination. Additionally, KCl is used in fetal intracardiac injections in second and third trimester-induced abortions. Jack Kevorkian's Thanatron machine injected a lethal dose of potassium chloride into the patient, which caused the heart to stop functioning, after a sodium thiopental-induced coma was achieved. Precautions: orally, potassium chloride is toxic in excess. The LD50 is around 2.5 grams per kilogram is about 190 g. However, this is not far from oral toxicity of sodium chloride, of 3.75 grams per kilogram, thus potassium chloride is harmless for alimentation. But intravenously, without the step of digestive absorption, This is reduced to just over 30 mg per kilogram. Most concerns are its severe effects on the cardiac muscles. High doses can cause cardiac arrest and rapid death, thus the aforementioned use as the third and final drug delivered in the lethal injection process. References. Further reading, Lide, Dr., ed. CRC Handbook of Chemistry and Physics. Boca Raton, CRC Press. ISBN A0-8493-0486-5. Greenwood, Norman N. Earnshaw, Alan. Chemistry of the Elements. Oxford, Pergamon Press. ISBN A0-08-022057-6A.